Hello guys, I'm Anton. I come from Estonia, so there is a good booth I noticed outside to work in Estonia, so please pay really good attention to it. We really need a lot of developers in Estonia, and I come from a company called Kotlin, and this is really unusual company that we can work, we can talk to you about it as well during the break. So we do pair programming 100% of the time, for example. But let's get to the Kotlin. How many of you already use Kotlin? So some of you, okay. So I was asked to give my talk, which actually I already gave a similar talk 2 years ago, and but a lot has changed since then. So what I have here is an updated version. So to start talking about Kotlin is that how we can save Java. So Java, until like the fast releases that we started getting lately, every half a year, it was developing really slowly. So we needed to save that, and that was the time when Kotlin actually appeared. So you can see the differences of the two islands is huge. So Kotlin is much safer. So why not try to use it? And it took 6 years for the Kotlin to get to 1.0. A lot of effort have been put into it to make a good language. It's not easy to make a good programming language. And they even have changed the logo to a more modern one. So, and given the amount of time, it should be a perfect language. You know, during the same time, there was another thing being developed, which is, so programming languages are not rocket science, but you can also do the same thing for the same amount of time. So in comparison, the other languages, how long did they take to develop? And the most interesting one is there in the middle. So the most used programming language nowadays, JavaScript, was developed only during 10 days. So you get the picture why we have so much trouble with it. And Kotlin, the thing is that Kotlin is not a niche anymore today in 2018. So if we look at the Google trends, so this is the Google trends since the 1.0 was released, and you see a huge peak. So the whole trend is that you can see it's rising all the time. And the huge peak, do you know what is it? It happened around May 2017. Yeah, it was the Google I/O. So it became the official Android language, and of course it's accelerated the adoption even more. But according to the developers of Kotlin, they actually never planned for it. They never tried to make an Android language. They tried to make a general purpose language, and this is what Kotlin is. So nowadays it is used a lot in the Android community, but we in Kotlin, we use it mostly for the server side. And it's actually really good for server-side, or actually basically anything. So there is now also a Kotlin Foundation. So people were initially afraid that it's developed by a single company. What happens to the language if something happens to JetBrains? But now there is a Kotlin Foundation, which is actually jointly funded by JetBrains and Google. So Google now is taking Kotlin really seriously. They're investing money in it. So there is a lot more of a safety now with the language, that it's not getting disappearing anywhere. And of course, it's open source as well. So it's also nowadays is the fastest growing language on GitHub in 2018. And it's second most loved language on Stack Overflow also this year. So it's, do you know what's the first one on Stack Overflow? It's Rust. Yeah, but yeah, the thing is that there are some, a good story about from the company Basecamp, or previously 37 Signals, who are making the Ruby on Rails. So there was a thing that the DHH, the creator of Rails, he's like famous of being open about being in love with Ruby, with a programming language. And even the guys who work for the same company, they were blogging that they didn't get that until they started using Kotlin. And now they are in love with Kotlin, and now they understand how you can be in love with a programming language. So it's jokes aside, it's actually Kotlin has a really good feeling about it. So when you use it, you actually enjoy it. Apart from Java nowadays, I think I enjoyed Java in the late 90s and maybe in the 2000s, but nowadays it feels old. But with Kotlin, it's a completely different thing. So, and there's exponential growth of developers. So this year at the Kotlin Conf, they have announced that they have 1.5 million of developers. This is estimated by JetBrains, which is a really huge growth from last year when they had 200,000. And many Java frameworks that you use, they actually now are adding idiomatic support for Kotlin. And idiomatic is an interesting word that you hear in the Kotlin community a lot. It means that you can write Java code in Kotlin syntax, but once you learn language, you start writing more idiomatic language, or more like it was intended to be. And Kotlin is a lot more powerful than Java is, and it's good when your frameworks that you use, they also like offer the APIs which are more like at home for Kotlin. But you can use any Java frameworks as well without any extra layers or support. So ThoughtWorks Technology, rather, if you know this thing, they have changed Kotlin to adopt already, I think already last year. So that it means that there is no doubt in that Kotlin is the really thing that you should use now. And so that means that it's time to take it really seriously. So if you're still not writing Kotlin, you probably should. So why do I like Kotlin? It has modern syntax, little boilerplate. You don't have to repeat yourself while writing code, and it provides you the readability actually, because the code is read much more than it is written. Then it runs on the JVM, and the JVM is actually the most optimized virtual machine that we have. It's actually the best virtual machine from all the other virtual machines. So if you have any other language runtime, be it the CLR for .NET or it's for any other programming language, they are all much less optimized than JVM is. JVM is quite old, from 1995, and a lot of effort was put into the just-in-time compilation and these kind of things, so it runs really fast. And if you write in Kotlin for the JVM, you get this benefit. And of course, it's a really good Java interop, so you can use all of your familiar Java libraries and your existing code written in Java from Kotlin. So there is also the binary compatibility. This is something, actually, I was really big fan of Scala when it came out. I thought it's the next big thing. And but when I tried writing some real projects in it, I realized that there were really two fundamental problems. If we take the complexity out of the equation. So it's the compiler is so slow, so it actually slows you down your everyday work, and there is no binary compatibility. So every time the new compiler is released, you need to recompile your code and all the libraries that you use, and it's a complete nightmare. So really hard to migrate and stuff. Maybe they have improved something nowadays, but that actually drew me away from Scala several years ago. And there is type safety. So, for example, Groovy is also quite an established alternative JVM language, which is really good, really well good interoperability with Java, but it's not type safe. And writing a big project without a type safe language is actually a disaster. So I guess I know why people love dynamic languages. You can be more productive at first, but when you need to maintain your software after several years, when it grew, you cannot refactor it well. It's really hard to refactor it. Even if you have a lot of unit tests, you need to refactor the unit test as well. So it's still quite hard to do that. And for the type-safe languages, the really good automated tools exist for refactoring, and it's really helpful. So I cannot imagine doing the stuff I do every day actually with a dynamic language. And the next thing is the nullability checks at compile time. So this is the big $1 million mistake that that was announced by the guy who invented the null. And and most programming languages have it, even Scala. And people all the time they are thinking how to cope with this problem. So how do I fix my code that I will not get a null pointer exception in production? And people invented optionals and this kind of crazy things that actually make the stuff more complex to solve a simple problem. And what Kotlin did, and they were the first language I saw this feature in was Vala. You probably don't know it, but this is they made the compiler actually check for nulls for you. And this is the same as with Java generics, with Java 5. So if you write a code that doesn't produce any warnings or compiler errors and it runs, you should not have the null pointer exceptions while running your code. And it's a really good thing, because it's also a documentation whether your code can return null or not. And by default, you cannot return nulls unless you really explicitly specify that you can. So there's also the backwards compatibility promise. We'll talk in detail how it's followed by the Kotlin team, but at least the promise is there. And unlike Ruby, Python, or like Scala, so there's only one language that has as good backwards compatibility as Kotlin is Java, of course. Java is famous for being really backwards compatible and really slow to change. In Kotlin, they have some tools how to prevent this slowdown for adding new features. I will talk about it later, but still they really promise it to you, and the code that you have written for Kotlin 1.0 still compiles and runs. This is a really good thing. So then there's the good IDE support. So Kotlin is created together with the IDE by the IDE company, so making it probably the best candidate for the best tooling. And Java, which was before absolutely the best language in the world in terms of tooling support. So now Kotlin actually inherits that, because it's developed by the same company who makes the best Java IDEs. And the thing is that they actually reusing the same code for the compiler and for the IDE. So it means that you will never get the desynchronization that you can get with many other languages. Like I have seen so many times, like Scala code that is read in IDE, but it actually compiles and runs, or vice versa. And with Kotlin, this cannot happen. And even with Java 8, it did happen at first. So that's a really good reason to use Kotlin. And the runtime that you get with your compiled code that you need to distribute is relatively small. It was under 1 megabyte, now it's about 1 megabyte. And this is also much better than most other languages that I have seen. So, and of course, it can also be compiled to JavaScript. Now it can be also compiled to native code. So Kotlin native was announced last year, and now they have already like a fully working compiler and tool chain and the IDE support. So you can actually write in Kotlin and compile your code to native code without the JVM. So they needed a lot for the iOS support, because you are not allowed to use virtual machines on the iOS. And of course, it's also really good for some smaller, like utility type programs that really need to start fast and don't need the whole JVM with them. And there is also a plan to support WebAssm. So instead of compiling your Kotlin to JavaScript, which seems scary to me, you can also, maybe now or in the future, you will be able to compile it to WebAssm and run it in the browser without the JavaScript overhead. So it will be much better. Like Kotlin is now being developed to become a truly cross-platform language that you can use to write code for anything. So you can write code for like your smaller microcontrollers, basically, or you can write code for the JVM or the web or the mobile apps and whatever. So it's, I think it's will be a really good investment to actually learn the language. And the incremental compilation is it was promised that it will be fast as Java. It's still not as fast as Java, but still is fast enough, and it's much better than Scala or C++. It actually doesn't get into your way when you're working on it. So usually you don't wait for the compiler. You just work and code normally. So coroutines is a new big thing in Kotlin world. So it's now finally, this is one of the features that Kotlin hasn't inherited from other languages. This is the unique feature of Kotlin that now they have recently released Kotlin 1.3 last month, and or even this month, and they now have the final version of the coroutines there. So, and they allow you to write completely painless asynchronous code that is so painless in most other languages, including JavaScript. And the basics of Kotlin. So if you haven't used Kotlin, let's quickly go through the things that you can expect from Kotlin. Let's look at the IDE. So you can write scripts without these are not precompiled things, you can just run them. Then, of course, this is the Hello World application. You just have a function without any classes. The function is the first-class citizen, and you can see it's much easier to write this thing than in Java. Then you can write classes. You can see classes don't need a body. You can extend classes. You can implement interfaces with the same syntax, and you can create new instances without the new keyword. So the Kotlin is quite concise. So you can see that you don't need to type too much to get things done. So they have tried to eliminate most of the things that are not actually needed, and it actually gives you some flexibility in some cases. So then there are the data classes. So the biggest problem of the Java language probably is the getters and setters and the inability to create small classes that are really useful for the good design of your code. Very often Java developers avoid writing small classes which are just for one use case, only because it's too cumbersome to do that. So in Kotlin, there is no such problem. You can make many classes, really short one-line classes, and you can use them nicely for additional type safety. So for example, this class hello has a property called message. It's also at the same time as also the constructor parameter, so you don't need to write it twice. So you just write message, and then you can create instances of hello by providing the value to the constructor, and it becomes the field, and this function can see the field and use that basically. And the data class is something that will generate the equals hash code and stuff for you, so you don't need to do that yourself. So if we run this program, so it will actually, the first one is compared by reference, because it's not a data class, it doesn't have the equals redefined, and the second one is actually has the equals redefined, so you can compare it. And of course the operator, this thing is the same as calling equals in Java, so you don't need to write like nasty code without like this. Using this thing is much more logical for readability. If you want the Java equality, the reference equality, you do it like that. Then all classes are final by default, so you cannot extend classes, Kotlin classes, if they are not open. So if you just have a class, you cannot extend it, and yeah, and it's a thing that I didn't like at first, but it actually enables a lot of language features by the compiler. So compiler can be a lot smarter for you. So if you don't allow extensibility of your classes by default, then a lot of smart casts and things can happen. And in most cases, you actually don't want your classes to be extensible. So making your classes extensible it should be like an explicit decision that you allow to do that. Of course, this creates some problems with mocking and unit tests, but I'll talk about it a little bit later. Then there is an object thing. So object is like a singleton class, is class with a single instance. So it's really easy to make them, and There are no static at all in Kotlin, because static is usually it's a bad thing for the design for anything in Java. So they introduced the objects instead, and objects can be passed by value around. They can implement interfaces. It's much better than static. And companion objects is a little bit cumbersome syntax in my opinion, but this is a way of creating object fields to a class. For example, if I want to have a class that I can create an instance of, for example, class can be instantiated, singleton cannot because it's an object, it doesn't have a constructor or a public constructor, but class also can have the class level fields, so like this, and for that you use the companion object syntax. And this is one of the things that the creator of the language, Andrei Breslav, said this year at the Kotlin Conf, that this is one of the syntaxes he is not happy about, but and they are thinking how to improve that. But this one actually works, and so this is how you make these kind of things. If you really want to make something static for the JVM, then you can use this annotation for the compiler, and only if you're compiling this for the JVM, then it will be static. If you're compiling it to JavaScript, there is no such thing as static, so the annotation will be ignored. So then some of the keywords are shorter, like you don't write instance of, which is long, and for casting you use the as, which is also like a good pair of the keywords, like is and as. You don't need so many braces. So in Java, sometimes you feel like you're coding in Lisp when you need to cast a lot. So in Kotlin, it doesn't happen. So then there is a really cool thing like properties. So in Kotlin, you don't have access to the fields. So everything, all the members of the class that you write, they are actually properties. It means that the compiler will generate getters and setters for you. And if you are using this class from Java, you will see the getters and setters. But you can control the getters and setters, of course. By default, they are, okay, this kind of property, yeah, it will have the default getter and setter if you want, and they will be also public, like the field, and the default visibility in Kotlin is public. And if I want to make the setter private, I can define it, and I can even define the body of the getter and setter, as you can see here. And there is a notion like, for example, this field, this property, it has a backing field, and backing field is hidden from us. This is somewhere where the compiler stores the actual value. But this property actually doesn't have a backing field. As you can see, we have overridden both the getter and setter, and they both, so there is no need for an additional field to store something. It uses this, the field of this property for storing stuff. And so there's only one field in this class. And of course, if you really need a field, for some reason, if you're making a Java compatible API or something, then you can again use the annotation for that. But it will still behave as a property in Kotlin code. So and as you can see, the syntax is much better than it is in Scala or in C#. Is that you don't need to write your backing fields by hand. You can actually access your backing fields inside of the getter. For example, if I implement a getter here and I want to return the value of the field, then I can access the backing field with this keyword. So I don't see it directly, but I can manipulate it inside of the getter and setter. And you don't need to introduce things like that, like let's make another thing that I will now return from the real num. So something that you do in C# or Scala. So they have taken some good ideas from many languages, and some of the ideas are improved as well. So they made it better. And there are no primitive types. But for example, there are nullable and not nullable types. So if you have an int, like a variable, of course, you can see the idea says that you don't need to define the type if it's obvious anyway from the code. So the compiler is type safe, but it's always trying to derive types for you. So you don't need to define types, many types, you don't need to define them by hand. And this is something that makes it feel like you are using a dynamic language, but in fact it is completely type safe. So the thing is that in Kotlin you never have to specify something twice. You can always do it once. But as you can see for here, I make it more obvious for you. So the int, the I here is of the type int, and runtime is mapped to the primitive type int in Java on the JVM, but you still can call methods on it. So because it's actually, there are no primitive types for the Kotlin compiler, so you can have all kind of methods here that the int provides. And if you want to have a, if you have a nullable int, like the int that can have a value of null, then it is mapped to integer in Java. So this is a really short introduction. Okay, another thing is that the exceptions are unchecked, all exceptions in Kotlin. So they have actually seen that Java developers in the end didn't like it, so they checked exceptions. I think the idea of checked exceptions actually was good, but the thing how it was implemented on the JVM was bad. So they have made many exceptions that should have been unchecked. They have made them checked. So that was the pain. But in Kotlin, all the exceptions are unchecked. And the interesting thing, if you have heard about another modern cool language, which is called Swift, then Swift is so much similar to Kotlin, it makes me wonder. So Swift is a little bit newer, so maybe they have took some ideas from Kotlin, but otherwise they are so similar and they were developed at the same time. So probably they both understood that there is these are the good features that you need to have in the language. And there is one big exception or difference between Swift and Kotlin. In Swift, exceptions are checked. And this is something that they didn't have in Objective-C. And now they have it in Swift, and maybe they will understand the same thing that the Java community understood, that maybe it wasn't a good idea, but we'll see. Maybe there is a way of making checked exceptions work. I hope so. So the type system of Kotlin actually is really consistent, really nice. So the thing that the guy who has started working on it, he was like, he had an academic background. So he really put a lot of thought into the type system, and is comparing to Java type system is so much better. So there are like three base things that you need to know. So there is an any, which is the base class of everything, parent type of everything, and this is on the JVM is mapped to Java-lang objects, the same as in Java. Then there is unit, is a single value type. It's actually an object. So it can have only a single value, and it's equivalent of void in Java. But the thing with void is that you cannot use void with functional programming nicely. You cannot return a void or put it and have it as an expression. But in Kotlin, everything is an expression. So the unit is really useful. So that all the void methods that don't return anything, they all return unit. And this allows you to write a much more functional code than with Java. And there is nothing. And nothing is the type that puzzled me at first, and is actually, it cannot have any instances. And it's something when you tell the compiler that, for example, if you return nothing from a function, you tell the compiler that this function cannot succeed. So yeah, this is a good thing. It's mapped to Java-lang void at runtime, and it's another interesting thing about it is it's actually subtype of everything. So anything can be cast, or actually nothing can be cast to anything in the code. And this is weird, but it actually, and this is the type that the expressions like throws and return, this is the type of these expressions. And this allows for really interesting syntax. For example, I can show you quickly, like, you can write things that, for example, this thing is an int, and I want to check, I want to use it, for example, I2, and call a method on it. But okay, I cannot because it's nullable. I need to check if it's null. I can use the question mark to make the compiler shut up. And basically, it's like in Groovy, I just don't call the inc methods. If it's a null, I just return null. I don't call the inc method. But what if I want to actually, if it's null, I want to skip all the processing and not go further. I can actually write something like this. Return, and this is possible only because the type of the return exception is nothing. Or I can actually throw like illegal argument exception or something. And it's also possible only because this thing is actually an expression that returns nothing. So it cannot be instantiated. It just does its thing, but you can use it in the syntax in these kind of ways. So, yeah, and there is also the parallel universe of types. So if you look at these three types, it's actually the same as in Scala. It was derived from Scala, but there is a parallel universe of nullable types. So if we look at this diagram, you can see. So these are the base types of the language. So there is any, unit, and nothing, and there is a parallel universe of nullable any, nullable unit, and nullable nothing. And actually, nullable nothing is the type of just null. If you have a null without any type specified, then its type is nothing question mark. And as you can see the errors here, then actually any is a subtype of any question mark, and like unit is a subtype of unit question mark, and the same goes with your own types. So this is a really consistent, if you like keep this in mind. So this is really beautiful actually how it's done. No exceptions to this rule. So this is really the most consistent type system I have ever seen. So the Kotlin is nowadays also multi-platform. So it can, initially I thought it was like a better Java, but now it actually contains its own std lib. This is the runtime of 1 megabyte that you need to use. And it contains some own types for Kotlin, like strings and collections and stuff. And at runtime, they are mapped to the respective types on the JVM. Or if you compile your code for JavaScript, then the matching implementations are used there. But the thing is, it has its own standard library that you can use on any platform. Of course, if you use any of the JDK classes in your Kotlin program, you cannot compile the same program to JavaScript or native. And yeah, they're implemented differently. But the cool thing is that most of the language and with the core library is completely portable. Let's look at the state of Kotlin promises that they promise us. So like the Java interoperability. It's actually, they still support Java up to Java 6. This was made for the Android, because Android initially it was stuck on Java 6, then it was stuck on Java 7, and maybe this is the reason why Android community was so happy to actually adopt Kotlin. So it's the interoperability is much better than Scala or Clojure. It's because it's the runtime types of Kotlin, like the Kotlin string or Kotlin collection or list, they actually at runtime they are using the Java types. So you don't need to convert any data between Java and Kotlin code, unlike Scala. With Scala, you need to do that because Scala has its own list, it's incompatible with Java list, and you need to convert data in order to pass objects around. So with Kotlin, it's much better. So, but there are unexpectedly many differences with the syntax. So they try to make a better language than Java is. So the access modifiers, then the way how generics works, and the new keywords that actually are valid identifiers in Java. These are the differences that you get. So probably the keywords is the biggest thing when you convert your code from Java to Kotlin. You can realize that you are using the keywords, so you need to change them, or you need to write them in backticks so that the compiler will accept these names. Some of the Java libraries, they use also keywords like the most famous is probably Makito. Makito uses the function called when, and in keyword when, in Kotlin keyword when is a keyword, so it's inconvenient to use when, and there are some, of course, there are some other mocking language libraries for that. So there are some small like use cases where you even cannot call some Java things from Kotlin, which weird code that exists in Android API, but there are always some workarounds for that, like you add braces around and then it starts working. So, but some of the Java concepts not easily expressible. One of the things that I don't like that Kotlin doesn't have the package local access. It has the internal access instead, and internal is not. They tried to improve on the package local access. So package local, they said that it doesn't give you the real encapsulation because you can always put the other code in the same package and get access to the things which are there. But with internal, they made it so that it's internal to the compilation module. So only inside of this compilation module you can access it, and from the other you cannot. But if you're writing an application Kotlin, I don't find it's really useful. So either you divide your code into many modules to get more encapsulation, or you just have to use public. So this is, for me, it's there's the visibility between private and public is missing. So there should be something more useful, and it is a heavily voted feature, so probably they will add something. And of course, there are annotation, as I show you, for making your API more Java compatible. So if you're writing API for Java clients in Kotlin, then you probably need to use these things a lot. But if you're just writing your Kotlin code, you don't need them. So then there is also, was like when Java 8 came out, it came out after Kotlin was already existed, and Kotlin have added a lot of extension functions to collections and stuff, and Java 8 introduced the streams, and there were some method clashes with Kotlin collections and extensions. So they had to introduce things that, like the general rule of thumb is that if you have extension functions in Kotlin, but there is a real method for that object with the same name, same signature, then the compiler will prefer the real one. So you cannot hide the real method with your extension function. But with for each, they have made an exception. So if you're writing the Kotlin code on like a Java list on Java 8, so you will use the Kotlin's for each method instead of the Java owns. So there are some, and nowadays actually the standard library, there are separate versions of standard library. So depending on which JVM do you target, you can choose which standard library to use. For example, you cannot use streams, Java streams easily if you are not using the Java 8 compatible standard library. But the thing is that you never need to use streams in Kotlin code. It's much easier to use the Kotlin zone, filter, map, reduce, and whatever instead of the streams. And streams are much more verbose. And of course, all the Java JVM languages, other than Java, they have trouble incorporating new features that are coming to Java. But I think so far, Kotlin has shown that they are handling it really nicely. So then there is a notion of platform types. So when you have a mixed Java and Kotlin project, and this really works, then if you use a Java type from Kotlin, it's called a platform type. And the thing is with this type that the compiler doesn't know is it a nullable or not. And before 1.0, they have tried different versions how to handle these platform types, whether to consider all of them not nullable or all of them not nullable. They were bad solution. So the current solution is quite good. So if compiler doesn't know if it's nullable or not, it allows you to write any code as if it were nullable or not nullable. But the faster you annotate the type that you receive from Java with either nullable or not nullable, the better. So then the compiler has more information how to handle this variable later. And if you are using some variable, some data coming from Java class as a not nullable type, then Kotlin will add the nullability checks at runtime. So if you're using it or passing it around in Kotlin as a non-nullable type, and in fact it will be null, so you get the illegal argument exception or something like that really fast. So before you get into trouble later on with this null. And of course you can annotate your Java code with nullable or not null annotations, and then the Kotlin compiler will see them and handle them properly. So since 1.3, there is a new feature in the language also, that is inline classes, which is a really, really cool thing, is that you can wrap your string or wrap your int in a meaningful class, but at runtime it will be just the underlying instance that will be passed around. So this allows you to have a better abstraction at compile time, but you pay nothing for the runtime performance with this abstraction. There's a really cool thing is that I think it also relates to the Venkat's talk today in the morning, that you should use better abstractions. So the mixed project, they really work. So they actually worked hard on that, and no any other JVM language worked that hard on mixed projects. It meaning that you can have a Java class and a Kotlin class, and they can use each other, which is actually not a good thing in terms of design, but it's possible. And they do it. They have implemented it the way that Kotlin compiler actually parses Java source code. So if you have your mixed project with two languages, then Kotlin compiler will run first. It will look at the Java classes. It will detect their structure, and then it will compile Kotlin classes that use the Java classes that don't exist yet. And then the Java compiler will run. It will already see the Kotlin classes, and it can fill the gaps with the Java classes. So this is the thing, and this is why you get a little bit slower performance out of mixed project compilation, because the Java sources need to be compiled, or not compiled, but looked through twice. But in reality, it's not a big problem. It's a good feature for introducing Kotlin gradually into your Java code base. So it also supports annotation processors, even for Kotlin classes. So the interesting thing is that at our big project, we even had, at one point, we had both Lombok and Kotlin working in the same project, which was a really scary thing, but it worked. So of course, after introducing Kotlin, we worked really fast to de-Lombok and remove the Kotlin annotation, the Lombok annotation processor from the code, because as you can see, Java is such a cumbersome language nowadays. So that it requires a lot of this annotation processing frameworks, code generation and stuff that actually is completely not needed if you have a more flexible compiler that the Kotlin is. So it's much better when you are programming the real code and not with annotations. And there is a Control-Alt-Shift-K in IDEA. You take any Java project, you press this key in it, and your current class will be converted automatically. This really works. You need to, actually, I can show it to you quickly. I have some Java source code here. It's a code that doesn't know anything about Kotlin. I press Ctrl-Alt-Shift-K. It's converting. It tells me that it needs to change some other classes that use my code. And voila, we have a Kotlin code. Of course, it's not ideal. It's not idiomatic. It's Java code expressed in Kotlin syntax. But still, you can work a little bit and improve it. For example, you can see I cannot access a map using this syntax because I haven't configured Kotlin standard library yet. So I press the configure button here. It will add the Kotlin standard library to my project, and now this thing compiles. And here the problem is that the map get returns a nullable type, and here is not nullable, so I need to change it a little bit. So usually you change it a little bit, and eventually it compiles and works. So it's a pretty cool feature to start learning Kotlin and like trying to gradually introduce it to your project. So the collections, I told you, they are in runtime, they are Java util collections, but the good thing is that there is a difference between immutable and mutable collections. So this is, Kotlin is really enforces more immutability to you, like the better programming style. That's why by default, Kotlin lists, Kotlin map and whatever, they all immutable. So if you want to have a mutable collection, then you need to declare it so. So that is mutable, and then there is a put method or add method, and compiler actually checks for immutability for you, but at runtime they are still Java util list, for example, so you don't pay any performance for that. So it is like a hard-coded Scala-like implicit. It's actually magic in the compiler. And most collections have a lot of useful methods, additional methods like filter, map, and whatever. They're all inline extension functions, and meaning that, let me show you some extension function here. Like the extension functions is a function that is a feature that came from Groovy and C#. So you can define your own extension function, for example, on a list of strings. And even this strings is important. So I can call this, then I can call this function on a list, but I cannot call it on other type, or even list of ints. I cannot call hello. The compiler will check it for me. And all of the standard operations that Kotlin provides in standard library, like filter and something, they're all extension functions. They actually don't implement it as a part of list itself, but they are like, for example, filter is an extension function to any iterable type, and like this. So it's a really cool thing. And because these functions are mostly inline, as you can see, there is an inline modifier, meaning that the compiler will actually not run this function from your code when your code is compiled, but it will replace your code with the implementation of this function in place, and that gives you better performance. So in many cases, Kotlin, filter, map, whatever reduce, they perform better than Java streams. So, and there are sequences, ranges, and progressions in Kotlin which actually can replace the Java streams. If you need the laziness of Java stream, then you can use this sequence, for example. Then the compilation speed. So it's not quite there yet. It's not, as I said, not Java-like, but is improving with each release. And it's much faster than Scala, has binary compatibility. It also uses the daemon, the compiler daemon, so that's to make the compilation faster. But in practice, the cool thing is that you have the incremental compilation, that they really worked hard on it. And they said that they are not introducing any new feature to the language that would make incremental compilation like slower or impossible. So they always, when they're designing new features, they are keeping in mind that the language should be easy to work with and fast to work with. So the IDE should be fast and the compiler should be fast. So that in practice it works pretty well. So you never wait for the compiler. And for the mixed projects, it can be a little bit slower, but we have quite a big project now, and it's really reasonable compilation speed. So the runtime performance, as I told you, is mostly delivered. Sometimes it's better thanks to the inlining, and but inlining, of course, have the side effect that if the inlined function changes, then probably you need to recompile the users of this function to get the new version of it. But in practice, it's never encountered it as a problem. And as sequence. You can use it for lazy collections. And the thing is that may slow your code down is that the compiler adds quite a few runtime null checks to your code. So I can demonstrate it also. So we have the nullability here. For example, we have the class runtime not null, and we take a string as a parameter here. It's no question mark, so it shouldn't be null. But I can fool the compiler and say that I'm casting my null as a not nullable string. And when I try to run that, I get the, okay, I just have an error here. Let me go back. So when I run it, I get the expected timecast exception. So actually it failed already here because I cannot cast null as this kind of string. But if I try to run the same method from Java, and you can see there is a warning that I probably should not be passing null here. And if I still try to do that, I don't get the null pointer exception later on, but I get the legal argument exception right away. And it's really verbose here that it also says the name of the parameter and the stuff to me. So it's easy to understand. When it fails, in reality, in a mixed project, it's very easy to understand where the problem is. And the backwards compatibility. So it's great so far, and at both source and binary levels, they are the big new features that they add to the language. They are experimental at first, requiring opt-in at your own risk. For example, coroutines, they were available for more than a year now, but they were marked as experimental. So if you use them, you know that they probably will change. And it happened. So now the coroutines are released with their final version. They are not experimental anymore, and they have changed. So you need to update your code. But the thing is that usually they provide migration for that. So for example, the Kotlin's deprecated annotation, it has the replace with feature. So even if you're designing your own API and you want people to stop using your deprecated API, you can provide the automatic migration for that, and IDE will migrate it for you. So you will not get stuck on your deprecated code, which is really, really cool. This is how they actually handling this problem that Java has. And there is a progressive mode of the compiler, so they are, if there are some bug fixes that little bit change the backward compatibility, they implement two versions of it. They keep the old behavior, and you can opt in for the fixed behavior until the next major release. So you can use the compiler in progressive mode, so then you will get all the slightly incompatible bug fixes. And of course, programming languages need a dictator, so to progress more quickly. Not like the Java did it before. So there are a lot of more exciting features in Kotlin. I think I'm running out of time now, so I will now only show you some stuff related to the unit tests. I think is quite important. So if we look at the unit tests, so Kotlin allows you to do really cool stuff. It finally gives you the possibility, even with JUnit, to have nice test names. This is one of the features that is worth writing your code tests in Kotlin. There are some extra libraries for Kotlin, like there is a Kotlin test that provides the DSL like this, so you can more fluent assertions. And what about Makito? So this is something like which is inconvenient. This is one of the libraries that is inconvenient to use from Kotlin code as is. So if you want to create a mock with Makito, you need to specify a class here. And of course, Makito doesn't accept the Kotlin class. You need to give it a Java version of your class. Then the when method, you need to write it in backticks because it's a keyword otherwise. And the second problem with Makito is that if you're doing it like here, if you're mocking a Java class, then you can mock it because it's a Java class today. But if you're mocking a Kotlin class, which is not an open class here, then you can have a trouble. And by default, if I now run this test, it will fail because Kotlin or Makito cannot mock cannot mock the final class. And one easy option is to go and add open to all your classes that you want to mock, but it's a bad option, obviously. And what you can do is that for Mockito, actually, there is a feature in the newer Mockito, like the inline mocks. You can enable it, and then Mockito will be able to mock your final classes. But in this case, Mockito will get slower. So we are not using that in our project. And we are using another feature, which is there are compiler plugins for Kotlin now, and you can introduce some annotations. Like, for example, I can introduce annotation, and which I call mockable here. And in my build script, I actually specify that there is an all-open plugin of Kotlin compiler that I'm using, and for this I specify for all-open that this annotation makes the all methods open in this for this class, and it makes it possible to mock it. But the thing is that you can even, if you compile your test code and your code for testing and code for production separately, then you can disable this plugin for your production build, and you can only use it in your while you're running your tests. So it's actually, you will not lose the final thing that you need in your production code, but you can have this annotation. In practice, we use, like if we're mocking, usually we mock some services in our code. And these services, if they are, for example, have the singleton annotation or something like that, then they, we use this annotation to actually make it all open so we can test it easily. So, and yeah, and the coroutines are really cool thing. So I'll show you just a little bit of it. Or maybe like the dependency injection. So this injection thing that you usually use in your Java code, like the choose or whatever, or the dagger, it's inconvenient because the compiler will not allow you to leave it as a non-nullable type if you don't specify the initializer for this field. So one option is to make it nullable and then deal with nullability, which is not a really nice thing. Like you will have to, everywhere you will have to write something like this or like this, because it is defined as nullable. But a better way is to actually, there is a feature in language called late init that you can tell the compiler that this is a non-nullable type, but I will initialize it later. So the injection framework will do it for me, so I can use it as a non-nullable type, and of course it will fail at runtime if it's still not initialized when I run it. But you can see the uninitialized property access exception. So, but it's a tool to make the Kotlin more compatible with other frameworks. But for Kotlin, there are better solutions exist. For example, you can write your own injection framework in several lines of code and use just a function instead of the annotations that will inject stuff. And the feature that is essential here is the reified generics. So this is a generic function inject that actually it sees this type parameter and passes it inside automatically, so I can actually use this class inside of my function. And I can actually declare it also as a lazy function. For example, there is a feature like by lazy and these kind of things in Kotlin. So if I need the lazy injection, I can do something like that. So it's much more powerful when you would use these annotation-based solutions that exist for Java. So I think that for the end, actually, I will tell you that it's no hype language, really. It's a mix of best features from Scala, Groovy, C#. It will change the way how you write your code. You will stop using magic annotations, bytecode manipulations, because you don't need them. And Kotlin actually makes it easier for you to switch to Java 11, for example. Nowadays, a lot of projects have troubles to switching to Java 11. For Kotlin projects, it's not a problem at all, because they don't use any magic. And I was productive with Kotlin even without reading the docs, but I still recommend you to read because the docs are really short and up to the point. It makes sense to just read them all. And you have the dynamic language field, but with static typing and create IDE support, you can convert to Kotlin gradually. Even Gradle now uses Kotlin by default. But be careful when you are converting classes like I showed you before, be careful because you will use your Git history. So if you commit, always commit the deleted Java class and the new Kotlin class in the same commit, so later you will still be able to track why some code was there. Because otherwise, unfortunately, Git sees it as a completely new file when you convert it. So thank you very much. You can look at all of the code in GitHub. I also have a lot of Kotlin puzzlers to entertain you. There are videos and there is code on GitHub as well. So thank you for listening.